Hello everyone, my name is Awad Al-Shammari and I worked on data pre-processing and classification and also regression in this project. In this presentation, I will explain steps 1 to 7 of our implementation. Our project focuses on analyzing drug-related deaths using different data mining techniques to identify patterns, make prediction, and gain meaningful insights. So we will start with step 1, which is import libraries and load dataset. In the first step, I imported the required libraries, mainly Pandas, which is used for data handling and analysis. Then I loaded the data set which contains information about accidental drug-related deaths. The dataset includes demographics features such as age, sex, and race, as well as drug-related variables like heroin, cocaine, and fentanyl and methadone. This step is important because it prepares the dataset for features processing and ensure that we can begin our analysis. So we move to step 2, which is selected important columns. In this step, I selected only the relevant columns needed for the analysis. These include age, sex, race, and drug-related indicators such as heroin, cocaine, and fentanyl, and methadone and any opioid. So this is important because it removes unnecessary data and focus only on features that contribute the analysis, which improves model performance and reduce complexity. So, and then step 3, which is convert data to numerical. In these steps, I converted the data set into numerical format because machine learning models cannot handle categorical values directly. So, I transformed drug-related columns into binary values, where 1 represents presence and 0 represents absence. So this step ensures that the dataset is compatible with machine learning algorithm and allows accurate competition. So we move to step 4, which is data cleaning. I cleaned the data set by converting all values into numerical format and handling missing values. Any missing or invalid values were replaced with 0. So this step is important because clean data improves model accuracy and prevents errors during training. And then after that, step 5, which is random forest classification. So in this step, I applied random forest classification model to predict whether a case involves opioid usage. First, I split the data sets into training and testing sets to properly evaluate the model. And then I trained the model using the training data and tested it using the testing data. The model achieved very high accuracy, which indicates strong prediction performance. This means that the model can correctly classify whether a case involves opioid usage. However, such high accuracy may also indicate overfitting, meaning the model may not generalize well to new unseen data. Therefore, techniques like cross-validation are important to ensure reliability. So after that, we move to step six, which is linear regression. I applied a linear regression model to analyze the relation between the features and age. The goal is to understand how different variables influence age. After training the model, I evaluated it using mean square error and R squared. The results showed a very low R squared values, which means the model cannot explain the variation in age effectively. This suggests that the relation between the features and age is weak or not linear, and a more complex model may be needed. At this point, I will pass the presentation to my teammate who will continue with the clustering anomaly detection and further analysis.
Hello, my name is Hussam Ali and I've worked on clustering, anomaly detection, and model evaluation. I will continue the presentation by explaining steps 8 to 12. Step 8, K-means clustering. In this step, I apply K-means clustering into group similar cases in the dataset. Clustering is unsupervised learning method, which means the model works without labeled data and tries to find patterns by itself. I selected 3 clusters to divide the dataset into meaningful groups. Each cluster represents a group of cases that are similar in terms of features like age or type of drug. This step helps us understand the data better because instead of looking at many individual records, we can look at groups and see common patterns between them. So overall, clustering gives us a clear view of different profiles of drug-related cases. Step 9. Clustering evaluation. After clustering, I evaluate the model using the Selhood score. This score helps measure how good the clustering is by checking how close each data point is to its own cluster compared to other clusters. The score was around 0.54, which means the clusters are responsibly well spread. It is not perfect, but it shows that the model is doing a good job in grouping similar data points together. The results tell us that the patterns found by the model are meaningful and can be used for further analysis. Step 10. Anomaly detection. In this step, I apply the Silhouette Forest algorithm to detect the anomalies in the dataset. Anomalies are unusual or rare cases that are very different from the rest of the data. The idea of this algorithm is to evaluate these rare points by treating them differently from normal data. If a data point is very different, it will be detected as an anomaly faster. Detecting anomalies is important because these cases might represent high risk situation or special cases that need more attention. So this step helps us focus on the most unusual and important data points. Step 11. Visualization. In this step, I visualized the data using different graphs as such histogram, bar chart, and scatter plot. Visualization makes the data easier to understand instead of just looking at numbers. The age distribution shows that drug-related cases are more common in certain adults age groups. This helps us understand which age group are more affected. The drug uses chart shows that some substances, especially fentanyl, appear more frequently compared to others. This gives us about which drug are more common in the dataset. The clustering visualization shows how the data is divided into groups, and we can clearly see how similar cases are placed together. Overall, these visualizations help us understand patterns and trends in a simple and clear way. Step 12, Anomaly Visualization. Finally, I visualize anomaly detection results. In the graph, most of the data points follow a normal pattern and are grouped together. However, there are a few points that stand out, and these are the anomalous. 3 points are different from the rest and may represent rare or unusual situation. By visualizing them, it becomes easier to notice these special cases instead of missing them in the dataset. This helps in deeper analysis and better understanding of unexpected patterns. In conclusion, this project shows how different data mining techniques can be used to analyze real-world data in a simple way. We use clustering to group similar data, evaluate to check the quality, anomaly detection to find unusual cases, and visualization to understand everything clearly. Each method gives us different insights, and together they help us build a complete understanding of drug-related cases. These results can be useful for future research and can help in making better decisions based on the data.